Hello, this is Neil, the art instructor at masterpaintingnow.com. And so this tutorial, and sorry guys, I've been away a while. I've been busy with holidays and my grow and everything. All right, so with this particular question, I can't use the photos that they offered. So, and I can't actually put like Iron Maiden. I can't make a video of Iron Maiden because that is an art pitch of Iron Maiden because it's copyrighted. But the question is how does light work with the face? Like, why is it that on a photograph, it looks different than this 3D image here. That is, in a photograph, you're going to get more highlights in here. You're especially going to get a highlight on the rim of the nostril, so right around this area. You're going to get light all in this area here. You'll get light all in this part over here. This part right here will be lit up. You'll get light on this area here. Depending on how strong the light is on this side that is here, you'll get some light on that part, but it won't be nearly as, it'll be more like that. And you'll also get maybe some light here. You might get a little bit more light in here. Not much more, but just a little bit. Anyway, to get the idea, there'll be a couple of differences, and why are those differences compared to a 3D program? When you use a single light source of 3D program, why aren't those areas lit up? The reason why, unless you have a really good 3D program, it's not taking account into bounce lighting. So you have to think about the shape of her face here. The shape of her face kind of goes like the grid goes up and like this. It's not a flat plane, right? So you have, if you think about it as flat planes first, if you've taken my head course, then you know that you kind of imagine a flat plane here first. That's like one flat plane. The other flat plane is with the nose, right? On the other side over here as well, and then the flat plane here. So this goes up, down like that. So it's kind of like a ramp. So you want to think about the nose as being kind of like a bicycle ramp, right? That is kind of shaped like this. So you have the ramp coming up like that, and comes across, and the ramp comes down like this. Is the side view of the ramp, right? Kind of like a excite bike. So jump and go over and come down. If you imagine this as more of a three-dimensional shape, you might, going back in space, something like this. And this light, let's say this side's not receiving light. This top is receiving light. This side is receiving a little bit of light, but not as much because the light is more focused here, or rather, it's more focused all in this area here. So this whole bottom part here is not receiving as much light. And then this back part here is not receiving much light at all either. So if you think about the nose that way, as this kind of ramp, then you just kind of change the shape of the ramp a little bit. That is, now it kind of has a slightly curved dome on the top and more kind of curved like this. And so when you think about it this way, and then it kind of goes back in space, right? Just kind of doing this very quickly. You get the idea though. You kind of have this kind of curved aspect here. So because it's slightly curved, you're going to get a little bit more shadow on this side when the light's hitting it, and a little bit over here because the light's hitting this main area, right? Okay, so the cheek also, then if you imagine it having, oh, I drew on top of the photo. I don't know if I have enough back steps. Let me see. Probably not. Oh yeah, I do. Cool. Let's go back here. There we go. Right, so I'm going to make a new layer this time so I don't actually draw on her. If you imagine this cheek, like I said, you have this flat plane here and another flat plane going down this way. Right, so if you imagine the lines making flat planes, it's like that, right? However, if you smooth out the grid more, it's not so flat. You kind of have a curvature here, right? There's a slight curve to all these lines. Just like the nose is slightly curved here. It's not totally, they're not totally straight lines. It's not a flat plane. It's more of a curved plane. So if you were to view this from the side cut out, if it was a flat plane from the side view, it's going to look like this. That's a flat plane, flat cut out. But if that same side view has a slight curve to it, right? So this right here is if this was flat plane. But if it has a slight curve to it, which it does, then the side view is going to look more like this when you cut out of it, right? And all that's important to understand how the reflective light works. It takes understanding the shapes you're dealing with. So it kind of dips in, then it kind of dips up again. So you have a valley right here, right? So you have like a big mountain range here, you have a valley and a big mountain range here. So you take the, right, about, let's say they're not the same height though, obviously. The nose isn't going to come out farther than the cheek, but to get an idea, this valley right in here, that's where the least amount of, if there can be shadow, that's where it's going to hit the most, is in that valley, right? And then it just depends on whether it's reflecting, but over here, if you have this is kind of sticking out toward the light. So you got to think about the angle of the light. So the angle of the light is above her head and a little bit to it's toward us, above her head, and a little bit to our right, her left. So as the light hits here, this would be the last part of the light. It kind of starts tapering off because all this, it's rolling down and around away from the light. And then you have this kind of valley in here. You have this valley here, but then it starts swooping up here again, which is why you get some light picking up. So this here is like turning away from the light. This is picking up again and turning around, right? Imagine the grid, the shape of the grid there. And when you imagine the shape of the grid, you can kind of see, that's why the light is hitting here. Then you have a cast shadow blocking all this from the nose, right? So all this is a cast shadow from the nose. And if there wasn't a nose there, then you would be able to see all this kind of valley here, and all this would be lit up as well. But it's not lit up because the nose is casting a cast shadow right here. Now this turning point right here, this is the turning point where the light, this starts turning down a different direction, right? So you have the shape of the face here, the grid, and this all kind of starts coming down this way. And so that's why when you draw the basic face, there's two different divisions. There's a flat plane here and a flat plane here showing the division of this. So it's kind of like to imagine this part of the face here, it's like imagining a wedge or something. If you had like a slight wedge like this. So it's not quite it's not like the edge of a box necessarily. So it's not like this is the edge of a box here, but it is the edge right here. Right? An edge to a ramp that's not quite as steep. So it's not like a ramp like that, it's more like a ramp like this. And if you turn that ramp to its side, you can kind of see how you have the bulge, not the bulge. And you kind of round it off. When you kind of round off the ramp like this, then you get this kind of rounded look here, and it kind of drops down. Rounded, drops down, rounded, drops down. I know this sounds like a lot of talk, but all this is necessary to understand how it works. And so this person's having trouble figuring this out analytically. And I also work that way. I work very analytically, so I think that's why I'm good at explaining things analytically. So the light comes and it hits all these angles here that are facing the light, and it bounces light back up, right? So what happens is the photon travels down, bam, hits here, bounces off, comes up this way, comes up this way, comes back this way, comes back this way. It starts getting weaker as it comes back down that way. Other parts are hitting part of this lip here and bouncing up this way, right? Hitting this lip, so that they're all coming in, hitting, bouncing up this way. And because of that, if you look at a photograph, and I wish I can show you a photograph right now, but I have to buy the rights to be able to show it. I guess I could take a photo of my own face and show you that way. You're going to get a highlight right in this area. Okay, I'm using the wrong kind of brush to show you this with you. Right, so it's going to reveal some information within the shadow area that otherwise wouldn't be revealed. So normally, the information of the nostril right here, all this right here, this would all be not revealed as it's not revealed, but because of that slight bounce light, it depends on how high this beam is. If this beam's low enough, then you won't get hardly any bounce light at all, and you'll hardly get any visibleness within this nostril area. This area right here, depending on how bright the light is, how much their face comes out here. If their face is more rounded and flat, like a lot of guys' faces, you might not get much reflective light in this area here. But her cheeks look pretty, like they come out pretty far, and so you probably would get some more details, more information. So more information in the shadow area is revealed. Because remember, that's all you're doing is, this whole thing's a shadow. And I'm going to show you something in just a second, what I'm talking about there. All this right here, like over here, is probably also going to get some light because it's going to bounce off here and come up here. And so it won't be as bright as this. It's probably going to be more like that. So it won't be quite as intense, but you're still going to be able to see some of this detail. You might be able to see some of this detail here too. Just depends how deep this crevice is and whether or not the light bounces there. Some of that stuff, I usually always put that a little bit, but it's not going to be as bright as this one over here. This one over here is going to be a lot brighter because it's closer to the beams. The beams are like going bam, and they're coming back this way, right? And they're going bam, and they're going. And remember, the light's kind of coming out at an angle like that, right? It's kind of coming down from, imagine the point it's coming from, and it's hitting all those parts. And then as it hits these points, it's bouncing back up. And so you get some light back in there. At least this is how, how a computer programs handle it. It's how life handles it. And it's a good way to kind of, understand it or try to understand it. There'll be a little bit of light in there, like so. The darkest part is where that lid is, and that's always going to be true. Might get a little bit more light in there. It just depends on the light source. Again, I'm going to keep this one really not nearly as bright as that one over there. It looks bright over here in relativeness because see, it's darker all over here. So that little bit of light looks bright because of the relativeness of it. You'll get a little bit more light in there. This side, because it's going to bounce here and up there. So you can get a little bit of light in here. Because remember the shape of everything. I remember the form. This is why it's so important to pay attention to the form of the face. When I talk about the form of the face, this whole piece is a form. It has shape to it. It's not just like a flat piece of material. And that's why I recommend sculpting the face, because when you sculpt the face, you kind of get a feel of the form of the face. So you have that lower eyelid, right? Which is, if you take a piece of clay, you rolled a piece of clay into a sphere, then you flatten that sphere out until it's kind of like a hot dog. Then you taper the ends out. Then you kind of curve it like this, and then you want to just kind of flatten it down so that way it's not sticky. So it's like you take a hot dog like this, and you cut it to where only part of it like that. So the rest you throw that part away. That's the amount of clay you have left, and that's kind of the shape here if you think about it that way. So it has these roundness to it, right? So when the light hits, there's also roundness to this. So the light might be hitting dark on the bottom here. And you kind of see the way you shade it. If you take my form course, you kind of shade this part as if it's kind of like a cylinder sort of, or half of a part of a cylinder. So you have the cylinder, and it's like you're cutting off part of that cylinder, and you're kind of shading it like that. So bottom part receives some shadow more than the top part, depends on what angle the light's hitting it from. So if you go through that course and think about all these as basic shapes first, which is why I break down the face into its basic shapes, all those will start making sense more. This all right here indents inward, right? So it's like it goes back into space, and this part here comes out toward us. It's the same as the bottom lid. And then you have this part here, which kind of comes out and away. It comes up, right, toward us and toward the light. So this part is able to get direct lighting. That's not actually reflective light. You get some reflective light coming up this way as well, but this right here is direct lighting from the light coming down. It actually hits it because that curves out away. And it depends on if someone has like a big brow here, that part really sticks out. So from the side view, they have this really big thing like Frankenstein or something. Then they have the eye coming in here, and they have that piece of skin. If the light's hitting at a certain angle, it's not going to hit this soft part of skin here. And so with that kind of person, you're going to want to draw all this dark because they have more of that Frankenstein look. In fact, Frankenstein would have that look. And it might even get a little more reflective light in this area here. Won't be that dark though, but or that bright. Like just a little bit revealing some of the detail. So really, and also if you have any sort of bounce light, there's a wall near her or anything that any sort of lighter substance, whether it be a light wall, especially if it's a white wall, is offer some bounce light. So the light's coming, hitting the wall, bounce at the wall. It might add a little bit of detail in here. It might reveal some of the detail of the face here. And so basically you're paying attention to the detail of the face, and so if you imagine a face is completely black before light hits it, depending on how much light you put onto it, sorry about that, I'm gonna mute my phone. All right, sorry about that. So yeah, anyway, so what I was saying is that the closer the light source is, the less area it reveals because it's only gonna be a hot spot here. And as you move the light further and further away, you're gonna reveal more and more of the character, especially like if it's a sun, which will be like direct lighting. Anyway, the more light hits any of this, it's just gonna start revealing, details of that side of the face. You might get some bounce light coming up this way, and so it's going to reveal a little bit more of the detail underneath the lip here. It won't be quite as dark. You might get a little bit more bounce light come up the bottom lip, bouncing up this way. So it bounces off the lip and bounces back up to the top lip, and it reveals some of the detail of that top lip. You might even get a slight little bit of wrinkles in here and some of these little details that come out because it's bouncing up and revealing them. And sometimes that might be hard to figure out logically, like figure out where the light's coming down. Okay, I know the light beam is coming down, and it's hitting this part of the lip here and bouncing back up. Okay, this part of the lip kind of sticks out a little bit, so there might be a little bit of light there revealing that form, a little bit of this. As it gets further over here, it's not as bright, and so there's less intense light bouncing up from here, and therefore the intensity of the light should get less as it reveals details in this direction. But if you study a lot of photos, it'll help you kind of derive that. You can derive it better. You'll be able to think more about it logically as you study photos. Don't study other people's artwork. And this is the person that's asking this question asked me a lot about other people's artwork. Artists make mistakes, so don't study other people's artwork to understand form and lighting. Study photography. Study real life objects. Set up lighting systems and with real life objects. Okay, so that's a little bit about the face. I wanted to show you something with the 3D program here. Oh, and the reason why I like to make videos to answer certain questions is because I think that it's helpful to other people, to other artists that are also struggling with the same question. They might be wondering the same exact thing, and if I answer it in a video, then all those people get benefit from it, and they might have been too shy to email me or ask me the question, or request a video on it or something like that. So it can benefit more people that way. Right. So this is the exact same thing here. Now, if I take the light source, this is using DAZ Studio 3.1. I just prefer it better, I think, for some things. Anyway, so you take this distant light here. And if I turn the intensity of the light, you'll notice that it doesn't change really the overall shape of anything. It's just in changing the hot spots, the intensity. And if I go ahead and render that out really quickly here, you can see that it has brighter, but other than that, it didn't really change much of anything by changing this here. If I move the light though, take the up and down movement of the light, well, first let's go ahead and recenter it. If I recenter the light, you'll notice that you get a very boring picture. And then especially if I take it, right now it's above the character, if I take it in front of the character, now you'll see it's very, very boring. Now to get an idea where the light's at, let's go ahead and zoom out here a bit. Let's turn to the side here. Okay, where's my light source at? Hold on a second, maybe it's down further. There it is, okay. I'm going to go ahead and take this, I'm going to just translate up. It doesn't matter where this is at, since this is a sunlight. That is, it's like if you go to create light, this is a distant light, so it's acting like the sun. It's not like a light you can put closer or further away from her. So if I move it further and closer, it's not going to make any difference. This is just to show you. Okay, that's still too far. Hold on a second. Okay, I need to change the background. Hold on. Right, so if you want to know how to change the background color, you go like this. It's right here. You go to background color. And it pops up a new window. I'm going to change it to like a kind of a sky blue color or something. This is just where you can see the light there. Okay, it's still really far away. Let me go ahead and move it a little bit closer. I kind of want to represent where it's at in space, sort of, that we kind of get an idea. Right, so as you can see, it's in front of her, but it's pretty much directly facing her. So let's go ahead and make it more directly head on. Which one does that? There we go. Now it's pretty head on. Okay. Now let's go ahead and zoom back in here. Okay. So as you can see now, the face is very boring. It's not revealing like any form at all. Let's go ahead and render this out. So the only form it's really revealing is a little bit of the nose, because this part of the nose is receiving more light. These parts turn away, as if you imagine a lamp or a ramp, like the ramp here goes up, down, and comes back down, right? So this part of the ramp is receiving the light. These parts are turning away from the light because they're going diagonally away from us, since the light's just facing directly at her. It's not above her, it's not below her, it's not to the left, not to the right of her. It's just directly facing her face. To get a picture like this, take like a flashlight and flash it right and put it right on a person's face, not too close, you'll get really hot spots, and just directly dead on her face. And it's very boring. It's kind of the similar look you get if you take a camera and only use the camera's light to light the person's face. It just looks boring, especially if it's a decent enough brightness light. It doesn't create much shadows. You get a little bit of shadows in here, and that's only because that's turning down away from the light, right? All this is out facing light, forehead, all this facing light. You get a little bit of turning away from the light with this plane here, a little bit with the bottom of the lip, but for the most part, this is very boring, and you don't want to use this kind of lighting, in my opinion, for any sort of art. Right, so if you take this light, though, and you start turning it to the right or the left, you start getting drama. See, now you start to hide some forms. And so this whole part, but still, like we discussed before, the light is, even though it's coming directly from the side, let's go ahead and zoom out here. Where is that light? So, okay, gotta zoom out more. Right, so you can see the light, the direction of the light is almost directly from the side view. If I rotate this more, that's directly a direct side view. It doesn't matter that the light's above her. It's not really above her. This representation's above her, but the light source itself is not above her. It's not a globe. It's just coming directly from the side. So it's way over here somewhere, the sun, and it's just going directly at her like this. And as you can see, now only reveals like half of the face, right? But that's not very desirable. So what you're going to want to do is move it to where it reveals a little bit more of the face. Maybe something like that can be desirable, a little bit, something like that. But you're going to get some bounce light hitting back up in here, and this program doesn't show you that because it doesn't have like particle physics or whatever, like a really good 3D program would have. It might take a while to render with particle physics, but they're getting better and better at it. If we take this now and move up or down, actually let's go back to the center again really fast. Okay, kind of centered like this. Now if we go up or down, we can start getting some drama. This is coming from directly from below and coming directly from above. And you'll notice that you'll get all kinds of shadows, and that's what creates the drama. Notice even when the light's coming directly from above, it's not directly above, it's kind of toward her, right? You get the idea, but that's how this is still being hit by the light. Now what happens, let's go ahead and adjust this a little bit. And let's come down a little bit further like that. All you're doing with your secondary light source, it's going to create a secondary light source here. In photography, if you create a secondary light source, it's by using either a secondary light that's not quite as bright as the other light, because if it's equal in brightness, you're going to remove all these shadows and you're left with that same boring thing as if you just use one light source facing them, like a flashlight just touching all of the face. That's going to be very boring. So, but if you use too much shadow, there's not enough detail in the shadows here, and it might not be desirable. That's for a certain kind of look. Let's say you don't want the shadows to be so hard and so dark and hiding information. Then what you can do is you create a secondary light source. In photography, what you do is you would bring up a your secondary light source would be. I'm trying to see if I can zoom out here. Okay. So anyway, your secondary light source would be either a reflective surface, like a whiteboard or something like this, or a light bulb that wasn't as intense, or a lamp that has some film over it to make it less intense. In this program, we just go down, we make sure we have our secondary light source selected, and we just simply turn down. Now if it's not on at all, you get dark, but notice how all those shadows, all that's happening is the shadows start slowly going away. Now what I'm going to do is I'm going to take this first light source, I'm going to turn it off for a second. Okay, hold on a second, what happened here? It used to be that you can just there's a little eyeball next, I don't know why it's not there. Usually there's an eyeball and you can click it. Okay, I don't know why that's not there now, but maybe it's on new versions I got used to. I'll just turn it down this way. So I want to turn that completely down, take light source 2, let's turn it up. Notice it's just directly facing. So what we're going to want to do with this light source is make it the opposite of the other light source is usually what you want to do. So let's go ahead and turn it this way, like so, and then make it come upwards like that. Also, I want to make it a different color. So I'm going to, just to show, make it kind of a bluish color, let's say, like this. I'm going to go back and turn this light source back on, and watch what happens as I turn it on. Okay, I'm going to turn it on really bright. So now we got like two competing light sources on opposite directions. Let's go back to this light source and start turning it down. So notice really all it does is it takes mainly these shadows over here and it brightens them up. That's its main purpose. That's all you're trying to do is reveal some details in here, and that's all you do with your secondary light source. And notice now almost looks like a single light source is hitting her from the top here, sorta, except for there's more shadow on this side of her nose than the other side. And it just depends on how much you might want to brighten that up. Let's go ahead and render this out. All right, now this isn't the most perfect program when it comes to rendering, but you get a pretty decent idea here how, notice there's detail being revealed into the shadow now. You can see some detail. Now naturally you're going to get more of a highlight here. You'll get more highlights here and here. Now this is all stuff that the program's not advanced enough to capture yet. That is, you need a program that actually has a particle photon, basically a virtual photon type emitter, where photons are bouncing off surfaces and reflecting everything. And I actually had one of those a while back ago, and it was really slow, but it actually did a decent job. And I only can imagine with how fast things move. We probably have a pretty decent program now. I haven't used one yet, but I'm sure we have a pretty decent program now that does that. Now notice the light in the eyes. This is just standard. It doesn't change with the lighting. I think maybe Dash Studio 4, the lights might be real-time rendered with the lighting. I'm not sure, but this is just pre-rendered, so it doesn't matter how you change the light. That lighting is not going to change. In real life, it will. So these are things you want to keep in mind and know about. So you want to know this has a certain shape to it, and the light's going to bounce and hit. These have certain shapes to it. The light's going to bounce off this part of the nose and reflect up into here and make this lighter. So this isn't a perfect representation. Again, for that, you want to study photography. All right, but this does give us an idea, I think, of gives you a good place to start at least. And it'll look realistic enough if you did draw something based on the shadowing. Hopefully that begins to answer your questions that you might have about the human face and how light works when it hits it. I'm going to go ahead and erase her. There's another question that was asked, and that was about a sphere. So let's go ahead and drop a sphere in here. Create a new primitive, and we'll go with sphere, accept. I'm also going to create another primitive. I hope this works right now because in version 4 I couldn't get to work. It was another reason why I went back to this version if I can show something here. Let's create a cube. Make sure I have the cube selected, and I'm going to no, that just moves it. I'm going to scale it. So let's make it big, but I'm going to go ahead and squash it. I think this one squashes. There we go. I want to squash it down to like this. Now I want to grab the sphere and move it up a little bit so it's touching like that. Okay. Let's go ahead and zoom in here. What I'm going to try to attempt to do here, let's go ahead and render this out, make sure. Right, cool. See, that's what I like about this version better is I can't figure out how to do this in version 4, but anyway, you can see this is a low-res sphere, so it has a lot of different planes. You can see the planes. I can actually take that sphere and make it higher res if I wanted to, but I think I have to go to its properties or something like that. It's been a while since I've done that on this program. But notice the hot spot is here. This is the brightest part of the sphere. This is where the light is centered on, right about here. And so if you imagine a line going around the sphere, like remember the sphere is made of a bunch of lines. Like if you imagine it as a wire mesh, and you can actually view this as a wire mesh in this program. But so you have this line coming around here. It's that part that's the brightest right here. So you follow that line all the way around, and it wraps back around to the side of the sphere. And that's the opposite side of that is me with the shadow. So notice the light's hitting this side, so the shadow is being casted on the other side of the sphere. And no matter where this light hits, the shadow will be cast on the opposite side of the sphere the light is hitting. So if the light hits over here, the shadow will be casted this direction over here. It'll be underneath and around like that, right? Let's go ahead and make this rectangle bigger so we can see more shadow. Nope, not that way. I'll go ahead and undo that. Okay, let's see, make this one, there we go. So those two make it big. All right, let's go re-render this again. Right, so what you can see here then is the brightest part is in this area here. And so on the opposite side of the sphere, if you imagine a line going through this sphere and hitting the opposite side, that's the side the shadow is being casted on. Right, so first you have the form shadow. The form shadow, the darkest part of the sphere, is exact opposite side of where the light's hitting. So the light's hit here, the darkest part of the sphere is on the other side over there at the sphere is see-through. And so the shadow is being casted in that direction. I don't want to confuse this. So the light, if you imagine an arrow coming down, the arrow is coming down this way. So yeah, the shadow's going in that kind of general same direction of the arrow, but the shadow's being formed on the opposite side of the sphere, the brightest part of the shadow falls on the opposite side of the sphere, the dark side of the sphere. This is the bright side of the sphere. The other side is the dark side. The shadow falls on that dark side of the sphere. So it falls down, not here. Right, so if we change the light, let's go back to one lighting here for right now. Let's go take lighting 2. Let's turn it all the way down. Take light 1. Let's move it around a little bit here. So if we come, let's go back here directly to the front and come down a little bit. This will be very boring. Watch what happens. So what you're going to notice here is that hardly any form is revealed at all. You could barely even tell we're looking at a sphere on top of some type of flooring because the shadow is being hidden behind us. The light is hitting the sphere like this, almost directly facing the light like a camera, like the light on a camera. If you have a video recorder, you're just recording someone. This is that boring lighting you get that we had on the face as well. It doesn't reveal hardly any form at all, and therefore it's also hiding the shadow. But if you take it and you rotate it to either the left or right, for example, even just doing that, let's go ahead and move it a little bit further down so it's hitting the direct side here. Okay, let's go up a little bit. Try and get the, okay, now I want it to be the direct side view, so let me try to get that. So here we go, okay. Now we got it hitting, it's hitting directly the side view. If I make it brighter, come on, work. It kind of pushes the, see, it almost is like how close the light is to the object. It acts similar. The brighter you make it, it almost acts like it's getting close to the light. This is all washed out, so you're not going to, it's going to be white. You also lose information when you white stuff out. Almost the same thing as a shadow, so you don't want to lose information, so you want to kind of keep it like that. So notice the hot spots here. I want to move that hot spot directly if I can. I don't know if it's going to let me. Directly to the side. That looks like that's as close I'm going to get to an exact side view, which is going to be kind of boring too, but let's go to render it out. Right, so it makes for kind of a boring composition as well, or boring lighting system, because you're only seeing half of the sphere. It's like a planet out in space. Well, not very, sorry about that. I was paused still. Anyway, this makes for a slightly better lighting system because we can see the form much better now. The light is what reveals the form of an object. It's what builds the 3D-ness of objects. If you don't shade right, your objects are going to appear flat on your page. They're not going to appear very 3D. But if you shade them correctly, they're going to look 3D. No matter, as long as you get the form right, which means you get the lighting right. The lighting reveals the form. If you use a boring lighting system, then you're going to get a boring form, regardless whether you're using sorry. I used to have a starting problem when I was a kid. My brain goes faster than my mouth. Regardless of whether or not you have a camera or not, you're going to get boring pictures if you're taking pictures of the sphere and you have a boring lighting system. You know, you're just using the camera on the light on the camera rather. You're going to get a very boring sphere. It's not going to look like much of a sphere. But if you use proper lighting, you can get a sphere that looks quite cool. Anyway, so on the other side of the sphere and this side of the sphere, we can see half of the brightest part, which is here. On the other side of the sphere over there, that's the other brightest part. Now to understand that, I really recommend getting my course Form, Lighting, and Perspective. It's going to make drawing things like this so much easier, but there might be some things you get stuck on, and for that you can write me an email, and I'll make a video like this answering it the best I can. If I want to reveal information on this side of the sphere, I either need to rotate my light around to try to reveal some of that, but now I'm losing the shadow quality, or I can make a secondary light source. And I just kind of turn the intensity up, and it's hitting that side of the sphere, and it's hitting kind of lower, so maybe I want to hit it higher, so I kind of rotate the highness here, rotate it around a little bit more. And let's say I only want to hit part of it like that, so I still want a dark shadow, then I'd have the light hitting this side and this side, leaving the middle here to have a dark shadow. So it depends on how close these two lights get toward the center of the object on how much of the shadow you light up. So if I want a lot of information lost in this area, I can do that. Now it still looks like a sphere. The secondary light should have actually cast another shadow, but I don't know if maybe I didn't turn it on. Let me see. None, shadow type. I should go to deep shadow map. Let's try it one more time. And so now what we should see is two shadows, one darker shadow over here and one lighter shadow over here. If the program's working correctly, that's what we should get. Okay, there we go. Notice this shadow is much deeper than this shadow over here. The reason why is because this light isn't nearly as intense. Now this creates a pretty interesting 3D quality, but I don't think it's as 3D as if we would have just gone with something like, let's go with something like this instead. Let's turn this down even more, and let's change the position of it to where all we're going to try to do with this is kind of light up these shadows a little bit. I don't want to light up the bottom shadows too much because I want that bottom part to be, to really show the roundness of the form. This should work pretty good. Might even have to turn that lighting down a little bit. All right, so now I'm recording again. Cool. So you can see this reveals the form a little bit more than the previous one. Notice where shadows overlap when you have two different light sources, and this only happens when you have more than one light source. When two shadows overlap from two different light sources, they multiply and make a darker shadow, right? It's almost like they're two different layers on Photoshop set to multiply, and it makes the color darker. However, if you have one light source making two different shadows overlapping, let's say you have another object in here. In fact, let's go ahead and do that real fast so I can show you what I'm talking about. I talk about this in the course too, but I just want to go over this for just a second and hopefully it answers some other questions people might have had. So I'm going to turn that light source off and I'm going to create another object here. The object I'm going to create is going to be cylinder. And let's go ahead and move it. Well, first let's go ahead and change the scale of it. Oops, I got to select the cylinder to do that. Here we go. Make it tall. Oh, that's wide. Which one was tall? Guess it was that one. I just got to get it tall. Okay. Now let's go ahead and let's move it. Let's say over here. Move it back this way a little bit. I want to kind of make it to where the light hits it. And let's see if I did this right. You should be able to see its shadow as well. Might need to zoom out a bit actually. So notice its cast shadow is being cast onto the sphere, and then it's being added over here to this. Notice this shadow here doesn't get darker. It adds to it. It doesn't add to it as in making it darker. It just becomes part of that shadow. So when you have two different objects and their shadows are crossing, they're the exact same color. They don't change the color. Only thing that'll change the color of the shadow is other light being reflected off the ground and bouncing up. Notice this program doesn't use bounce light. So bounce light would actually hit off the floor here, bounce up. It reveals some of the details in this part of the sphere. It'd light up this part of the sphere a little bit. Not very much, but it would light it up enough to see some of the details. And that's the downfall of programs, unless they have a good lighting system, like a good particle system or something that take account for reflective light, then you're going to kind of miss out on that. All right, so hopefully that answers all the questions. I think the exact question was, though, about the sphere is, why is it that when the light hits here, the shadow seems to kind of come behind the sphere? And notice, if the light is hitting here, if the light go above the object a little bit like this, kind of toward us a little bit right here, something like right about here, the light will kind of go behind the sphere a little bit. So most of the shadow is being covered by the actual shape of the sphere. Remember, the ground's down here. This is how much of the sphere is touching the ground down here. So the shadows going to be casting on this ground, coming out like this, and coming out like that. And that's something like that's what we should get. I'm just kind of going by it feels like intuition, but it's hard study. It's years of study and practice and looking at photos and taking photos and okay, I was a little bit off. So the light looked like the bright spot was here, but it's actually over here. Okay, see how it looks like the bright spot's there? That's not my fault. That's the program's fault. I want the bright spot to be right about here, and so I guess this isn't actually representing the bright spot that gets rendered. Now the bright spot should be here. This should be the brightest spot when it gets rendered, somewhere right on here. And if so, then the shadow will be where I said it would be, like that, going behind the object. There we go. So now notice now the brightest spot is more right around this part of the sphere. And if I bring the brightest spot to the directly here, not directly here, but more above and right here in the center, the shadow would go behind, and it might actually be completely hidden by the actual sphere itself. If I make it down here more, the shadow will be longer, and so I'll be able to see some of it going behind it like that. Right, so here you can see the shadow is being dropped down like this. If I bring the light source and come above the object some more, what we should see is the light source being casted like kind of behind the object, but still more underneath, like that. Okay, so now actually, so it's really hard to tell where the light source is on this sphere before you render it. But anyway, it ended up being almost directly on top. Because it's almost directly on top, then you get if it was directly on top, the shadow would be all the way around like this. Anyway, I'm not going to go into all that. I go into it in the course, just repeating myself. But if I kind of make the light more right here, then the light is going to go more towards the back than the front. Because the way the light's hitting right now, the shadow kind of comes at us more. To change that, I would have to make sure the light source is coming, make it still to the side. That's from underneath. On top, I need the light source to come at us a little bit more. Like, let's see if that's right. That's still not quite at us. Okay, so all right, so now I was able to get the light source a little bit, see more, now it's more toward us. The brightest spot, which is right in this area, is more toward us. And so the shadow, now if I bring it more even toward us this way more, then the shadow would go behind the sphere more, and you'd see less of it. It'd just be like a sliver, and then it's mostly being hidden. So when you're studying spheres, and you're getting caught up on, well, why is it looking weird? Just think about how the light hits the object and where the shadow should be. So if the brightest part of the light is hitting this part of the object here, then you can expect the shadow to be dropped on the opposite side. What I mean by the opposite side is this is the side of the light, this side is the light side object, this side over here, which we can't see all of it, is the dark side object. The shadow is being cast toward the dark side object. In other words, the shadow is not coming over here. This would be the same side. If the shadow was over here, that would be the same side as the light. But the shadow does follow the line of the light. So the light is coming down this way. If you imagine the direction of the light, it's coming at us like this, hitting the object. So it's moving from right to left. Boom, like that. Boom. The shadow is also going that same direction, right to left, right? So it's like boom. So in that way, it's going the same direction. But so that maybe that's what we got confused about when I said opposite direction. It's opposite of the light, meaning opposite of the side of the object that's light. It's on the side of the object that's dark, not on the side of the object that's light. If it was on the side of the object that was light, the shadow would be over here, and that doesn't happen. Now, I think this program does handle this. Let's go ahead and see if it does. If you take that same light, let's go ahead and zoom out here a little bit, and you move it to the side view, let's see here, then the shadow, I need to have it come up a little bit though to show the floor. The shadow should be very long. It's like as if the sun's setting. Yeah, see, we get a very long shadow. It extends way out. And that's what happens when the light hits a side of an object, like let's say the closer the sun gets towards the horizon during a sunset or a sunrise, you'll notice your shadow is very long and skinny and distorted. And your legs being the longest part of the shadow. Anyway, I go over that too in the course, but I just wanted to kind of show that really quick in this program that is what happens. So when you're drawing things like faces and legs and arms, just first keep in mind the basic shapes that make up that object. So you imagine an arm is built up of basic shapes. Go ahead and turn that program off in the background. So imagine the arm is built up of basic shapes. Let's go ahead and let's go and fill this in with something. The hell, might as well do a long video. I haven't done one in a while. I'll be making a VIP video soon as well. Right, so you have let's say you have an arm. So first thing about the basic shapes that make up the arm. This will be like the shoulder area. You kind of imagine it like an egg, and it has a shape to it. It's not flat. So you want to imagine it having the shape to it, or rather kind of like that. So you imagine that shape kind of like a shoulder pad. And then when you have the other part of the arm coming off of it, you also imagine this arm has, this part of the arm has a shape too. So you have the shoulder coming down into here, and then you have this tricep muscle, and the tricep muscle has its own shape, right? And you want to imagine like a grid onto it. Then you have the muscle between. You have your bicep here, and the bicep has, a shape to it as well. And so the light, if it's kind of hitting this arm, you have your elbow. Muscle comes around here, muscle back there. Anyway, so as you draw this arm out, You have your neck muscle coming in here, and the chest muscle, and so forth. As you're drawing out the shapes here, we want to imagine where the light hits. So let's say the light's kind of coming from behind. So the hot spots are here, hot spot hits here, hot spot hits here. This all kind of turns away from the light almost altogether, like that. But the light might be hitting a little bit more here than anywhere else. So, you know, the darkest spot is going to be here, and then all this is going to be dark, right? All this is going to be dark here because the light's not hitting in there, but the light is hitting a little bit of the rim here, so it leaves some light. But anyway, a faster way to do it is kind of fill it in like that, and then kind of start coming back in where you know light's going to be. Like, okay, light will be hitting here and there a little bit. It's not going to be as dark here or as bright there as it is there. You have like 3 different lumps, you know, to your deltoid, and so you'd kind of show that by how you light it. Maybe like show a little bit of this for the deltoid maybe getting lit up. Anyway, I don't have the time really to get really deep into this, but this is how you think about it. You have a cast shadow here from the shoulder a little bit onto the chest. All this part's darker, a little bit of light up there. That part of the bicep. All this part down here is darker, being hidden by the light, so it's turning away from the light. A little bit more light's hitting here, a little more light's hitting that muscle there. But not necessarily as bright as all the other lights. You don't make the light necessarily the same brightness everywhere. Right, so as I slowly start to you know, render this out, you start getting something like that. And the light's coming from, you know, back there, so all that's going to be, you know, lit up more. But you can start to see how it takes shape, and that's, even though this is really, really done very quickly, you can start to see it taking shape just because of I'm paying attention to the form. So form is really what reveals lighting. And okay, that time it popped up on another screen. I don't know why it keeps doing that. It's really starting to irritate me. Sometimes it pops up on the screen like it should. Other times it pops up on the screen. And you want a good change in contrast as well. Your darkest parts, you know, the darkest part might be like right here, and all right here where it's turning away, and then you might have like a drop shadow right there. But this might be the darkest parts. Maybe somewhere down here. We get another dark area in here. And so, yeah. It'll take a while to render it out to make it look more realistic. But you start to see it take shape, and then you use smaller and smaller brushes, and you'd have some parts where you have bounce lighting coming back, and so you have this crevice here, and where that crevice is, you'll often get slight brightness of light hitting the crevice part where you have one form folding to the other. That is, you have this shape, and they're kind of folding into each other. And you have this deltoid shape here, and this bicep shape, and they're right here is where they're folding into each other. And that kind of creates a crease like that where the light is going to be bouncing and hitting it. Also be another crease there. Shadow on this side. So it's like a rolling of the forms where you have a shadow and light, and that's like where things are creased together, and that happens. All right, so I'm not going to do it too much more, but I just want to kind of give a general idea. So to imagine where creases would be, you want to think of where shapes are hitting each other and overlapping each other, and that creates like a strong crease or a strong contrast. So in other words, there are no hard lines in reality. How you get the appearance of a hard line is a contrast of light and shadow. And where you have a dark shadow and a brighter light next to each other, you get what looks like a line. You get what looks like a crease. And that happens when you have two shapes on top of each other. Like if you have, let's say you take a sphere, right? You start with a sphere shape, and then you kind of cut it. So what I have left is this part here, which is kind of like sort of like a deltoid, right? This shape here. So now I have this partly dome shape of, like this, and it's attached, and it's on top of another shape. Let's say the other shape it's on top of is some kind of like cylinder shape here, like this. This being the part of the cylinder that's cut out. Oops, it's coming this way. So now what I'm looking at is kind of like the end of a like something like this, kind of like the end of a cigar or something, or a cigarette. And this is only partly, this is kind of hanging out over it, right? So all this part of the object is hanging out over this part of the cigarette. It's only being attached right here. Well, right there where it's attaching, if you have a light source coming down, let's say almost straight down, so this is the hot spot. So I'll use yellow. This will be the hot spot here. And as we turn down away from this light, you get like shading. All right, so let's go make this brush a little bigger. And it kind of fades down like that. Maybe make this a little bit brighter, the brightest spot. Okay, so it kind of comes down like that. What's going to happen is you're going to have this like kind of a, this all be like in shadow, but maybe a little bit hit by the light on the other side. What's going to happen right here, when the light comes down and hits, is you'll have like a crease, a little bit of the light, and then you'll have all the shadow still. Right, and then all this is going to be shadow being hidden away from the light. Darker here than up there. But that little crease right there is caused by contrast of there being a little bit of light hitting there and there being shadow on near, either on both sides or on one side of it, and it causes what looks like a hard line. Anyway, that's really funny looking, but that's how you get a hard line in reality, what appears to be a hard line in reality, where you have a shadow and contrast hitting it hard. So if I were to like really bump up this lighting, for example, let's say on the bicep, and the light, I bump up the lighting, kind of move it, and I go, okay, that's not what I was trying to do. I was trying to use this. So I bump up the contrast here like this, and all this light now is hitting here, and it's hitting it hard. It's really close to the object. I'm only talking about the bicep right now. So it's really close to the object, and the shadow is like this then. This happens in metals. And since the shadow, and even if I use a soft brush, doesn't matter. What's going to end up happening is I'm going to get what looks like a hard line. And the reason why that's happening is because you have the bright right next to the dark. Let's say we have all this kind of being lit up a little bit from another lighting source. It's like a bounce light and whatever. It's kind of lighting up that side, but it doesn't light up this part here. And that's how you get more of a metal look. You can only get that on some kind of shiny surface like metal, where you get that hard line there. But that's caused by the bright light hitting it, and then the shadow still be remaining hard. And so when you have contrast of heat, or a value, a contrast of value, which is how dark or light something is. So value, like turn an object into black and white. And let's go ahead and turn this into black and white and see what happens. Right, so what will happen here is it just turns down to the values of things. Notice the value is really different between these two colors, well now shades. And since the value is so different, you get what appears to be a hard line. But if I were to take the values and change them, so I would take a value that's closer to this here, watch what happens. Take that exact same shape, just change the value of it. So hard lines are caused by relative values next to each other. And these are still pretty different. They're different enough that you still get what appears to be a line, but the line's not as hard. And if I take it and I make it really close to this, or I make it to where it has more of a fading effect, you know. But what I'm going to do is I'm going to take a color that's very similar to that. And in fact, here, let me go back with the hard brush if I can demonstrate this better. I'm going to take a color that's almost exactly the same as that, and it went to the screen again. What the hell? Okay, so let's just make it a little bit brighter. So that's how dark it is right now. We're going to go up, make it a little bit brighter like that. The line, the hard line, is not nearly as pronounced because the colors are closer together. And if we fade the colors more with like a gauze or a blur effect, you kind of fade these colors more into each other, then suddenly the hardness goes away. And in reality, how that works, I can even still brighten up like that, and there's still no hard lines there because there's this gradient fade between. And how that works in life with lighting is if the light source hits an object and it kind of just slowly fades out over the object, it won't create a hard crease or a hard line or the appearance of a hard line. But if the light moves closer to two objects rolling over each other, that's all one object. The only way I can get, let's see, how do I explain this? If I have a sphere, and I'm gonna do it the fast way. Just add a gradient to the sphere, boom, and make it a round gradient. Okay, I'll reverse it then, fine. I could have also reversed the colors down here. In fact, here, let me go ahead and reverse that. I'll reverse the colors and we'll get the same effect. Right, so let's say you have a sphere here. As long as the light source, the colors aren't too different or the values aren't too different, you're not going to get a hard line. But notice you kind of get what appears to be a hard line right here. And if I go like this, you can start to see the hard line. You can see another hard line down here. What that's caused from is the color or the values being so different, so close together. So here, there's not much fade between them. But if I were to take the light and make it not as bright, do the exact same thing, you notice I get more of a gradient flow between them. And now if I do like that, I can get kind of a hard light here. But as long as I pull it down more, it's not there. So you can get a hard light even in real life with the lighting. You just have to take the light source and make it really close to the object you're filming, in this case a ball or something. You put the light really close to it, like a flashlight, and you get this hard, what looks like a hard line here. That's created in the photograph. If you have normal lighting, like let's say like this, right? And so now, even if I make this dark, as long as I have a good flow between them, you're not going to see any hard lines. And then if I add another object on top of this, another sphere, let's say, and it's obviously being lit the same way, what happens is you'll notice that there'll be also a slight drop shadow. Let's go ahead and draw the drop shadow in here really quick. And we'll just kind of estimate remember, this isn't a full sphere stacked on top of a sphere. This is like a zit on the face, right? So it's not a full sphere. It's not like a full sphere on top of a sphere. It's not like a snowman. We saw it from the side view. It's not like a snowman like that. Rather, it's more like this. You have a sphere, and then you have a bump on top of that sphere. So the rest of the sphere is going inside of the object, if you were to imagine it that way. So we're just dealing with a part of a sphere popping out, more like a zit. And in that case, then, the shadow is not going to be very big at all. Something like that. But you notice we still have, that covers up some of the hard line, but not much of it. Notice we still have hard line created. The hard line that's created is right here on this edge and right here on this edge. And the reason why there's an appearance of a hard line, even though there's no hard lines used, the reason why there's appearance of a hard line is you have the light color next to a darker color. That creates appearance of a hard line. You have the light color next to a darker color. So it's when you have objects overlapping each other that create that effect. So when you have the deltoid, which is a shape here, overlapping another object here, which is the bicep, you get this overlapping effect. So what would happen is, let's go ahead and shade these two objects really quickly as separate objects. Take this object and we're going to shade it. I'm going to go ahead and go, okay. Let's take a light color and a dark color. Let's just kind of shade this object, and that's kind of where the light's hitting. So notice there's no hard lines in that object right now. And actually, let's go back. I need to make this, I didn't make this bottom part here dark enough. Like that. Okay, so light's hitting up there. And then I have the other shape, which will be this bicep part. And I'm going to light it the same way. So I kind of go light on the top, dark on the bottom. And then there's going to be a little bit of a drop shadow here, but not much. What's going to happen is you're going to get this hard line right here because you have the dark next to the light. But notice there's no hard line over here because they're the same color, but right there you'll have this hard and light. And then what's going to happen sometimes is you'll get like some bounce light, and it might cause a little crease right in there like that. And that bounce light is what causes that, what looks like a hard line. So you can actually paint with all soft brushes and just keep reducing the size of the brushes and putting hard, not hard and soft, sorry, putting dark and light closer and closer together. And the closer you put them together, the more the appearance of a hard line you're going to get. So you can literally paint an entire picture with soft brushes, but get the appearance of hard lines as if you used hard brushes, as if you made line art by just the contrast of colors next to each other. And also by taking that soft brush and reducing its size and putting the light and dark next to each other. So as I put that light and dark next to each other, what's going to happen here is I'm going to get the appearance of hard lines used, even though I didn't use no hard lines. See, it looks like a hard line right there, even though I didn't use any. And the smaller I make this brush, the more I can create that illusion of a hard line, even though no hard lines were ever used right there. Anyway, I hope that answers more than the questions you had for me. Just keep studying from real life. So still life, that is taking objects and people, even yourself in a mirror or just yourself in a camera, and flip the other end around to kind of see that you can adjust the lighting. Use one light, use two light sources, and so forth. When you add a secondary light source, really all its purpose is to lighten up the shadows. It usually isn't to change the shape of the shadows, but you can get some really interesting effects when you do that. You take the other light source and kind of move it to where you have this kind of line going down the center of the face or on the side of the face. You can get kind of interesting looks that way. So in other words, you have two bright lights on each side of the face, and you kind of have this like dark line kind of going down either the center of the face or slightly offset. And it's kind of an interesting look, but you can mess around with that kind of thing. When you're drawing from imagination, pull upon the knowledge that you learned and apply it logically and rigorously. And if you do that, you can figure out how to light anything. Just take the knowledge that's in my form, light, and perspective course. You take that knowledge and just apply it and think about it logically. Okay, this and that and the other thing. Don't get confused by the people's artwork. Go, hey, I thought I had this understood, but this artist did it this way, and maybe I'm doing it wrong. Don't look at it that way. Don't look at other people's artwork. Look at photography. Now, if you see something in photography that seems to contradict what you think would happen, then that's when you come and ask me another question and go, okay, I'm not understanding this particular thing, and I'll do my best to answer you. All right, thank you everyone for watching. By the way, if you're interested in growing marijuana, legally, of course, if you live in a place where it's legal to grow, or if you have like a medical card or something, even though it's still illegal federally, I guess. Obama's trying to change that. But anyway, in other words, they should be focusing their money on more important things like violent crimes and so forth, not on, hey, legally you can grow by state law, but federal law says you can't, so we're going to go and bust you or something. That's just ridiculous. But nonetheless, if you're interested in marijuana growing, check out my other channel. I will link to it here in the description. So I don't know how long I'm going to link to it for. So I'm just telling you guys now, I figured only the die-hard people would stay through and watch this entire hour-long thing. And if you also happen to be interested in growing marijuana, I'm going to be doing a lot of do-it-yourself videos. So how to make your own CFL hood lamp that produces 30,000 luxes per, that's basically the amount of looms per square meter. And that's within 6 inches away from the plant. So as long as you keep that hood, I can teach you how to make this hood. It's a 900 watt equivalent hood. It uses two 300 watt CFLs and it uses two 150 watt CFLs, and has warm and blue spectrum all mixed in together. The smaller bulbs are the blue, the bigger bulbs are the warm, so the 27 Kelvin versus the 65 Kelvin, 6500 rather, not 2500, 6500. And all together, you can keep it covers about a 1.5 to 1.5 square foot, square foot. That's pretty good footing for this lamp to be at 30,000 luxes, which is a lot of looms from being 6 inches away from the plant. Anyway, I can show how to make that. I can show you how to do low stress training to not mess up your plants. I'm just going to be going through all kinds of stuff. I already have one video on there now, which is really just a little bit of tips. For those, you guys know how I teach. For those that have seen my teaching videos, I teach every subject pretty much the same. I have this certain method of teaching, and it translates to any subject I teach. So I will also translate that into how to grow marijuana. And I'll go through the common mistakes and stuff that you make. I'll be answering questions. You can make request videos, things you kind of want to understand and so forth. I'll be going through my grows and just kind of having a grow journal. I also have a grow journal on 420magazine.com. Yeah, so if you want that, check it out. Link will be in the description. If for some reason the link's not in the description anymore by the time you watch this video, just shoot me an email and I can give you the link. Basically, just search for THC LED Grow. That's my name on the other channel. If you search for that, then you'll find it. It's pretty easy to find on YouTube. All right, thanks for watching. Oh, and go ahead and subscribe to that channel too if you're interested in marijuana growing. I want to try to get that channel built up and get people interested in it. The more channels like that we have, the more awareness we have, the faster it'll be that it'll just become legal everywhere, because honestly, it should not be illegal. It's less dangerous than alcohol. It's less addictive than alcohol. It actually has medicinal purposes, unlike alcohol. And that's one of the contradictions. I'm going to go on a rant here for a second. I'm done with the tutorial, so if you want to shut me off now, you can. One of the contradictions that they have with this whole marijuana thing is that it's a Schedule 1 drug, which means that there's three classifications for a Schedule 1 drug. One, it's dangerous. That is, it's dangerous to your body, dangerous to other people, whatever. Two, that it has no medicinal properties at all. It cannot be used for medicine. And that three, it is highly addictive. Well, marijuana is none of those things. One, marijuana is natural, right from the tree. You smoke it right from the branch. You don't do any alterations to it unless you make like hash or something. But you just take the bud, you smoke it. You're smoking what is naturally produced. Whereas, let's say something like heroin, which is also a Schedule 1 drug, it is highly addictive, it is highly dangerous, and it's not natural. It doesn't come directly from the plant. If you smoke opiate, that's a different high than if you do heroin. One is derived from the opiate plant, but it's not the opiate itself. It goes through a chemical process. Same with cocaine. If you take cocaine leaves and chew them up with lime, it's not going to give you the same high as if you snort cocaine, because cocaine goes through a chemical process and they extract the alkaloids and make an extract from it, and it's very different than the actual natural plant. And in fact, the natural plant is not even addicting, and people can chew coca leaves for a long time and drink cocoa tea. I don't mean cocoa as in chocolate milk. I mean cocoa as in from the coca plant, from cocaine plant, and they won't get addicted to it. Anyway, that's a side rant. But the point is that marijuana does have medicinal properties, and this is the contradiction. FDA approves Marinol. If you look up the pill Marinol, it's a prescribed pill that is THC. That's all it is. It's a THC extract, and so actually it's not the pure plant. So it's like the opposite of heroin, right? Heroin is a Schedule 1 drug, and it is a chemically processed thing. Whereas other chemically processed things, like made by the government, such as different opiates like Vicodin and Norcos, which are the same thing, which is hydrocodone. Then you have oxycodones like Percocets and just pure oxycodones, that is with no Tylenol in them. Those aren't considered Schedule 1 drugs, even though they're highly addictive, they're dangerous, and they're not even natural. But anyway. And I guess they do have some medical benefit. Anyway, so the government admits that, hey, marijuana has medical qualities to it, and if they didn't admit that, then why did they legalize Marinol, and why does the FDA approve Marinol for medicinal purposes, and why is it prescribed by doctors for medicinal purposes? That is the Marinol pill. So it obviously has medicinal properties. So it can't be a Schedule 1 drug if it has medicinal properties. Is it highly addictive? No, it's not highly addictive. What research shows that THC is highly addictive, that smoking marijuana is highly addictive? There is nothing out there that shows THC or smoking marijuana is highly addictive. I see people have a hard time quitting marijuana, but it's not because it's highly addictive. It's for the same reason you have a hard time quitting drinking milk. Does that mean milk is highly addictive? No, it just means that you're used to drinking milk, you like drinking milk, you like the way it tastes, you don't want to stop. In fact, try to stop drinking milk altogether. Try to stop eating dairy products altogether. You're going to have a very difficult time doing that. I know because I've done it. I've quit drinking milk for several years. I now drink milk here and there, but I don't drink it very often because I know it's not good for you. But try to drinking soda. That is non-caffeinated soda. Let's say you drink soda, but you drink non-caffeinated sodas like me. Try to stop drinking that. You might have a hard time doing that because you're so used to doing it. So that doesn't mean it's highly addictive. That is, you're not going to get sick if you quit drinking it. If you stop doing heroin, you can die. You can have a heart attack. You get very sick, and it's very stressful on your body, and that's why they usually taper you off of that drug with things like methadone. But THC doesn't have none of that. You can quit. You can smoke THC every single day for years and years and quit cold turkey and have like no side effects whatsoever, except for psychological side effects, the same way you would if you just quit eating meat cold turkey. So it's not highly addictive. So those are two dispelled right there. It's not highly addictive, and it does have medical properties. Well, there's two of the three that make something a Schedule One drug. So what keeps marijuana being a Schedule One drug? The last one of the three that has to qualify for it to be a Schedule One drug is it has to be highly dangerous. How is marijuana highly dangerous? There have been studies done of people driving vehicles while highly stoned, and it doesn't make much of a difference of their responsive skills as compared to alcohol. So alcohol is more highly dangerous while in your system. That is, you're more ample to make stupid decisions, dangerous decisions, kill other people while trying to drive your vehicle than with marijuana, yet alcohol is not a Schedule One drug. Now, alcohol used to be illegal, and then states started making it legalized. And then there was a contradiction between federal law and state law, and then the mafia got involved, and hey, we're going to make alcohol, we're going to still produce it, and we don't care what you say. And eventually it won, and everywhere you can buy alcohol, and you don't get in trouble for it. And I'm not even sure if it ever changed, if it ever became federally acceptable. I know there's still federal laws about transporting alcohol, making alcohol, stuff like that. But anyway, the point is, alcohol became legalized and marijuana is not. Marijuana has none of the three things that make something a Schedule One drug. Alcohol actually has some of the things that make something a Schedule One drug. I guess alcohol does have some medicinal properties, but for the most part, it doesn't. It is highly dangerous and it's highly addictive. Yet alcohol is not a Schedule One drug and it's legal. And marijuana, it just makes no damn sense. A huge contradiction. So big rant there. I won't be like really going on rants like that on my channel. I'll be going through, here's my grow, here's what I've done, that we can learn from my experiences, and then also I'll be doing do-it-yourself videos. Here's how to build a carbon filter yourself and save money. Here's how to build your own do-it-yourself sulfur burner. This is what you want to burn when you have powdery mildew. So when you notice that either gray or white, either puffs of white powder on the bottom of your leaves, or you notice any sort of graying on the leaves, this is the sign of the mold buildup. You want to use sulfur. You want to burn sulfur. Don't waste your time with all this stuff like copper sprays and peroxide sprays. You can still spray it with some copper, or you can still spray it with some peroxide and help kill the mildew and get it off. But if you really want to, control the situation, you want to burn sulfur. And I can show you how to make your own do-it-yourself sulfur burner with a candle, with a pilot candle. You can actually buy them for very cheap too at a dispensary, most likely. That's where I bought mine. But you can make one very simply. It's really easy. You can also make one with using the green bulb pretty simply and very cheaply compared to spending like $68 on one, which is about the ballpark range of how much sulfur burners run. So I'll be going through stuff like that, how to get your lights on the cheap and how to use your lights and how far away they should be and how to get the most out of your lights, how to do low stress training to try to get a pound out of one plant, and how it might be more beneficial for yield wise to grow one plant under a 400-watt lamp versus growing 3 or 4 plants under the same lamp. You can actually get more yield off the one plant if you do the proper low stress training than you can off all those other than you can off 4 plants under the same light. So if you have a 4x4 tent, you're better off just growing one plant or maybe two than to grow like 4 or 6. So anyway, just things like that and showing why to do it that way. Right now I am growing 6 plants under a 4x4 area, which really is not ideal, but I want to show the difference when you grow 1 or 2 plants. And I'm going to also show like autos and what things to do and not to do with autos and so forth. So all kinds of really awesome information, and it'll become better and better the more feedback I get from you guys and from the community. Hey, I don't understand this, and you basically, you guys being brave enough to ask questions, and then that will inspire videos, and hopefully it will become what this channel has become for artists, and it'll become that for growers, so people can grow their own marijuana and medicinally grow their own marijuana. That is, go get your medical card and so forth. Or if you live in Washington or Colorado, or you live in somewhere like Amsterdam, it'll help you grow your own medicine without having to waste so much money, because some people need it. Some people get highly sick off the meds. I've seen cancer patients where they tried all the different anti-nauseous pills while they're going through chemotherapy, and nothing worked for them. And these people, interesting enough, were very against marijuana smoking. That's how they were raised. But as a last resort, they're like, okay, I'll try it. and they tried marijuana, and sure enough, it helped their nauseousness. They were not nauseous at all while they're smoking marijuana while going through chemo, whereas all the high-tech pills they took didn't work. But marijuana worked for them, and so they kind of had to change their belief system about marijuana. Like, hey, well, I know I was raised to believe it was so horrible and bad, but here it is, and it's working, and I can't deny that, and it's not having any of the ill effects. The only ill effect marijuana has that's been shown through any sort of research is that it does slightly affect your short-term memory, and that's about it. So it's kind of worth it considering the amount of things that these other drugs do to you. Read the amount of things medically proven that the anti-nauseous drugs do to you, or things like Tylenol. You know how bad NSAIDs are for your liver and your kidneys. Look at it's common stuff you buy at the store like NyQuil and Tylenol and Advil and so forth, aspirin, versus the natural form of aspirin, which is from a willow tree. Anyway, look at things like the pills they give you, like Xanax, or the kind of diverse effects on the body and the side effects that things like, think of common things like Xanax will have. That's not Zoloft, Ritalin, which is basically medical speed. Adderall and Ritalin, that's all they are, is medical speed. But you look at the kind of diverse effects those have on your body. Short-term memory loss, having your short-term memory, not short-term memory loss, it's your short-term memory doesn't work quite as good when you smoke a lot of marijuana. There's no proof it's long-term effect. That is, it doesn't have long-term damage. If you don't smoke marijuana for a few days, your short-term memory returns, and it's working like it always was. But it's just a slight degradation in your short-term memory. That's such a small side effect when you look at the side effects that legal, well, I guess it's all legal, but how do I say this? Synthetic drugs. When you look at the kind of diverse effects synthetic drugs have on your body, they're so great compared to, oh, I have a little bit of short-term memory loss, big deal, or my short-term memory doesn't work quite as well as it used to before I was taking marijuana as a medicine. So when you compare them together, it's kind of ridiculous, one compared to the other. So the side effects are hardly any at all compared to the other types of drugs out there on the market that are pushed by the I guess all corporations really. Anyway, so that was my big rant. Woo, that was a huge rant, but hopefully it gets you interested and excited about growing your own medicine. Check out my channel. Oh, also, for those people that are just like, you know what, that's just too much work. I just don't want to do it myself. I don't want to build it myself. Can you just build it for me? I'll be able to do some things like that. So like, hey, I really don't want to build my own CFL hood. It just seems too complicated. Can you just build it for me and send it to me? I can do that for a price. I can show you the receipt for how much the parts cost. I'll say this is how much my labor will cost. I'll put it all together. This is how much shipping cost, and I'll use the parts that are the lightest. That way, it'll get to you the cheapest as possible. And if you're willing to pay all that, then I'll do the labor and build it for you. And it'll probably still be cheaper than if you went out and like bought the thing, itself. That is, if I were to build you a do-it-yourself sulfur burner, even after shipping and everything, it's going to be far, far less than if you went out and bought a commercial sulfur burner, and it's going to work just as good. Things like a hydroponic system, I build those. Things like, and you want to make sure you use the right totes when you build these things. Rubbermaid is the kind that don't leak. If you use something like Sterilite, it's going to leak on you. Check this out, easy cloners. So expensive. They're like 200 to 300 bucks for an easy cloner. The cheapest you can probably find one on sale is like 180 bucks. That's so expensive. And I can build an easy cloner or something that's very similar to an easy cloner, works the same way, the same principle, and I can build that for you and send it to you through, on eBay. And this is after shipping everything. I can get it to you for probably $100, $120, maybe even $140 after shipping, depending where you live. That's so much cheaper than $200. I might even be able to get it to you. If you build a slightly smaller one, I can probably get it to you for like, $100, $80 even. It just depends on how big it is and stuff like that. The things that cost the most on that are the neoprene inserts, and you absolutely need those for an easy cloner. So the more sites you have on it, that is, the more plants you can clone in it. So if you have like a 30 sites will cost more because each neoprene, the 2-inch neoprenes cost, I think it's 40 cents, 50 cents each, something like that. I have to go look again, but they're kind of expensive, and you times that by 30, that's 15 bucks right there at 50 cents each. So they get expensive real fast. So if you only have like a 15 site or an 8 site, if you do like a bucket cloner, a black bucket cloner, Building one of those is far cheaper. You can't clone as much at a time, but it still works just as efficiently. I can build you one of those, and after shipping everything for like maybe $60. So far cheaper. That's just like, hey, I can teach you how to do it as well, and that's part of what I'm going to be doing on that channel. But some people just don't want to build it. They don't have. I don't want to say they don't have the ability. They either don't have the drive to do it. I'm not saying they're lazy. It's just something they'd rather not do. They'd rather just like, you know what? I just don't want to do it. I'd rather spend my time doing other things. Can you build it for me? Or they just don't want to take the time to really learn how to do it. Or even if they want to take the time to learn how to do it, they're afraid they might not do it right. Because what happens when you try to build something like this is you try to like deviate from the instructions, and it's kind of what I did, and then you end up spending a lot more money in the long run. Use the parts that said to use, build exactly as it said, and even then you might still make mistakes. You might go, I don't want to go buy that drill. And also it takes having the tools. You need to have a power drill. You need to have a 2-inch hole drill, hole saw. You need to have the 1-inch rotor saw or hole saw. These are materials that cost money too. So you got to keep that in mind that, hey, when I want to go build this myself, not only do I need to go buy all the materials, but I need to buy the tools for I can make it properly, for it works properly and doesn't leak on me. And the tools can end up costing you a lot of money. And if you're only going to build one tote, then buying all those tools is you got to ask yourself, do I really want to do that? Well, I already have all those tools, so you can go like, hey, can you build it for me, and I'll pay you this much money or whatever. Like here's how much here's how much the parts are going to cost. Here's how much my labor cost. Or here I already have one pre-built. It's on eBay. Go buy it. I don't have any pre-built right now. I actually do have one pre-built. I have one cloner pre-built right now, and I'm thinking of myself like $100 on eBay. It's awesome. It works fantastic. It works just as good as Easy Cloner. Um, and as a dark Easy Cloner, you don't want to use the light tubbed Easy Cloners because the clear ones, you don't want any light getting to your root system. It's bad for the roots. So you want to use the dark Easy Cloner if you do get an Easy Cloner. But nonetheless, $100 is a lot cheaper than $280 or $230, I think, the smaller site ones run. Wow, I've talked a lot. Thank you for listening.